discusses today that there will be a recording later on that we will email out to everyone that is joining us today, and it will also be up on our Vimeo site and on our website under the events page. So we can move ahead into the slides. Again, welcome everyone. And so we're gonna shoot for a 30-minute webinar, 10-minute of Q&A, but really feel free to ask a question anytime during Vinaya's presentation. I'll be monitoring the Q&A and I can jump in and ask her a question as it's relevant as she's discussing it. So don't be shy with the questions. We definitely want to hear from you guys and want to hear all your questions. The other thing I'll just let you know is we cannot see you or hear you. So rest assured, if you just got done with the gym or something like that, your video is not on, we cannot see you. You can see us, but we can't see you and we can't hear you. So just a little bit of peace of mind there in case you were wondering about that. So today what we're going to cover is EdFi technology deployment journey. We're going to talk, Vinaya just gave me a great education about containers and the Docker architecture and why that's more valuable and why that can be a game changer for the EdFi community. Basics there of Docker technology and the toolbox, and then kind of talking through the entire orchestration of that. So with that, I will hand it over to my colleague Vinaya. And fun fact, we are both in South Austin. We live not too far from each other, but sadly, I haven't gotten to see Vinaya in person in over a year. So I'm excited to do this webinar with her. So thanks, Vinaya, and go ahead and take it over. Oh, I think you're on mute. So
I'm on mute, yeah.
There you go.
Hello, everyone. Thank you for joining us. I am Vinaya Maya, and I am the product owner for ODS API team. And I work with the development team day in and day out and do some level of development as well. I would like to start with an overview of EdFi and how exactly it connects to the Docker deployment that we are talking about today. EdFi is a nonprofit funded by Michael and Susan Dell Foundation, and at the heart of EdFi is the EdFi data standard, which is focused on the education data interoperability and basically defining a standard for storing and sharing edtech data for K-12 education. And for the adaptation, to make it easier for data standard adaptation, we developed EdFi ODS API, which has a ODS database and an API, REST-based API, that can be used to populate the data in the ODS. And then along with that, we do have a bunch of tools that would help us manage, administer, and analyze the data that is in the ODS. And so this is the whole set of spec suite, and along with these tools, there are also the deployment options that make it easier for EdFi hosts to deploy ODS API, ODS and the API. So that's where the Docker comes into picture under EdFi tools. Now, when the journey started for EdFi, the journey started with state education agencies mainly, and the SEAs usually they go through a set of data model customization, or what we call as model extension, and then they do have special needs for authorization. They do have special implementation specific for student identity API. So there are things that they need to change in the source code and then deploy that updated source code into their environment. So they usually went with the source code installation path, and they worked with the system integrators and then make the source code changes and then deploy it to their environment, which would usually take months to get it through and get it ready at staging, right? But that's what they need because they have customization, right? And they do have the budget to do that as well. And as like recently as the LEA's focus has come through, and LEAs generally, one, they don't need that much of customization. They work with the core product, and also they don't have the budget to go through the full deployment, CI/CD setup and then deploy the application, right? So that's why we developed PowerShell and as well as GUI-based installers to help them utilize the published binaries from it, right? Rather than rebuilding and retesting everything, they can use the published binaries using the PowerShell installers and then deploy the API. Now, this option is definitely wouldn't take months, but it would still take days because even though the PowerShell installer would install the app, it has everything that is needed for the app to run. But there are other components like configuring the host with the IaaS and say hosting bundle or configuring the SQL Server, installing the SQL Server or the database, right, for the ODS. So there are things that are not included in the PowerShell installer that they have to set up on their host and maintain the host, patch the host, administer the host, right? So there is still a set of things that need to be done on the PowerShell installer. So I would say it is probably days would be needed for going through the PowerShell installer and setting the environment up. Also, recently, a lot of school districts have switched to the cloud platform, and the cloud platforms for Azure, we have the ARM template deployments, and for AWS, we have cloud formation templates. Now, these are each cloud platform has its own technology, so we do have to implement different deployments for each one of them and maintain it through. As we upgrade ODS API and mainly data standard and followed by ODS API, all these different installer options, we have to keep maintaining them and progressing them through as well. So these are the deployment options that were there up until late last year. And late last year, we, along with the NetCore migration, we added the containers, or the Docker container support, and that's what is the focus for this session today. Now, the Docker container has a bunch of advantages over the technologies that I mentioned earlier. It is lightweight, secure, portable, and all that is needed for the deployment is coded in the Docker deployment. So all the details are in it. So I will go over a few of these again later in a slide that, especially the lightweight and secure, we will cover that later. But I do want to focus here on portability. So as I said earlier in the previous slide, that we have deployment specific for AWS, specific deployment for Azure, which is something that we need to maintain for every upgrade. And generally, there is a delay between, when the ODS API release happens and then when the deployment support comes, about a month or so or more delay when that gets updated. Now, with the Docker option, the same deployment can work with all the major cloud providers. They have, again, in them, multiple different options for deploying the Docker containers on their environment. Same thing can work on on-prem data centers, VMs on cloud, or your local development box. So the exact same technology that works for all different options. So that's I feel that's the greatest benefit of this option, right? So if you are a school district and if today, if you think the best option for you is on-prem, and then in a year or so you want to switch over, right, to one of the cloud providers, then with this technology, there isn't a learning curve, a whole lot of learning curve to switch over. So the same technology codes very well for any of the environment. Or if you're, even if you are talking about just on-prem, like testing between your development system and then the staging and production. So all that moves forward very smoothly because everything is codified already in the deployment scripts. So that's the greatest advantage I want to highlight over here. If Docker is so great, why we didn't do 2 years ago, right? So there were a bunch of changes that came in last year and maybe last 2 years, which make the Docker container support is really valuable are these. So one of them is migration to Netcore, which truly makes it cross-platform. So now that we have migrated to .NET Core, Docker deployment is supported on Linux containers. So that brings down the licensing cost quite considerably. And the second one is open source backend, which reduces the licensing cost on the database as well. So now with the PostgreSQL backend, there is no licensing cost for the database. And then Apache license as well for the ODS API source code. Though the source code was free for licensees, there was still something that the barrier of license, right, obtaining the license. So that isn't there. And then with that, we could host our Docker images on the Docker Hub without worrying about the licensing concern, rather than hosting on a private repository. Then the other major change was removal of server-side bulk load. This was a legacy code, and it depended on MSMQ, Windows tied service. So removal of bulk load, server-side bulk load, and then enhancement of client-side bulk load, which goes via API, kept the bulk load ability, but then the legacy code is removed. So with that, we could convert to Netcore source code. So these different changes that we did recently adds on to quite a lot value to the container. So the default Docker container that we provide, Docker images that we provide are on Linux Alpine and Postgres 11 backend. So then I'll move on to the basic container concept, just explaining what exactly is a container and different terms that are there in the container world, right? So a container is a software unit that is standardized. The standardized means the same thing works in different environment, right? And it packages up everything that is needed for containers to run. The runtime, all the settings, the system tools, libraries, everything is packaged in. So it runs from one environment to the other environment. So there's a kiddo in the background. Sorry about that.
I'm so impressed, Vinaya. You're able to like stay on track even by being super distracted. You're a superwoman. I love it. Don't worry about it. It happens to Maureen had the same thing in one of our last webinars, so don't worry. We're listening. We're listening.
Yeah. Yeah. So that's it contains everything that is needed for the containers to run. And then I just want to go over a little bit. So there are two terms that are frequently used, VM and container. So I just want to go over the difference between VM and a container. So in a VM, it also helps us utilize given system resources for multiple applications, right? In a VM, what it does is it is running on a technology called hypervisor, and what it does is it virtualizes the physical layer with virtualizes the network, the CPU, the RAM, and this is the virtual representation of the physical layer. And on top of that, you would run your OS, right? And then on top of that, your application. So if I'm running, say, 4 applications, then I need 4 operating systems running on one physical server. So that means I have 4 operating systems to maintain, patch, upgrade, licensing cost for the 4 operating systems. In the container world or the Docker world, so the Docker technology, what it does is it virtualizes the operating system. So there is one operating system which is consuming your system resources instead of like 4 operating systems that's consuming your system resources. So there is one operating system that you need to patch, that you need to administer and make sure all your ports, what is open to the world is like, how you keep the operating system secure. All that extra overhead that needs to be done is on one operating system. And on top of that, there is virtualized operating system. And each app runs one app per container. So that app is secure. There isn't a whole lot going on other than that app, right? So that container exposes only what is needed for the app to run. And there is a whole bunch of resources still left, because in case of operating system, it is like we are talking about tens of gigabytes of operating system source code, right? That is also consuming your system resources. In this case, it's a couple of MBs of application. So that's the big difference between VM and versus container, right? The same server can host probably a whole bunch of more containers compared to number of VMs it can host, and the licensing cost for the operating system is considerably reduced as well.
When you were telling me earlier that one of the major benefits is cost savings for an education agency, is that
Right.
This is where the cost savings would come in, right? Is that correct?
Yeah.
Like less resources allocated to maintaining 4 separate operating systems, and then you can use that one server more efficiently and effectively.
Right. Yeah. It also is a good benefit for developers. Like if I am vendor developer who wants to deploy, like right now, either they'll have to deploy ODS API in their development box. If I'm writing a client app that talks to the API, then I would either deploy ODS API on my local box and then run against my client application against that when I'm developing the client application, right? Or I would wait for a district to host SI ODS API on their environment, and then I would code. With this, I can deploy with one single click, right? One command, deploy the ODS API, and then code my application against it. If I have to deploy on my box as a developer, right, I generally don't like to install a whole bunch of things on my laptop. Even if I clean it up, there might be still a possibility of some lingering things. With Docker, it's like clean slate, install it and take it down, tear it down. If everything is completely gone because the container is gone, everything I put it on that container is completely gone when I take it down. So there is that advantage even for in a development environment for a vendor developer. All right, moving on. So there are a few key terminologies that come through in Docker, and just wanted to give a quick overview of what each thing means. I already mentioned what a Docker is. It's a container technology. I think I mentioned what container is, right? That it combines everything that is needed for the software to run. Docker is the most popular container technology. So it has the Docker daemon. That's what you saw earlier, right? Like here. So that's where your containers are running, right? So that's there. And then it provides it does provide command line interface for that helps for you to run, build the Docker images, build the Docker source code and, create an image. So it comes with the Docker runtime and as well as the command line interface. And then the image is basically a blueprint for the container. So when you run an image, what you get is a container. Image is what is built using what is called as a layered file system. So one image usually is based on some other image and a bunch of other instructions, so which all adds on to this layered file system. So it's a combined multiple layered thing that when you run, you get a container. And as I said, the image is a layered file system, right? And the container has one more layer other than what's in the image, which is a read-write layer. So, so if you have an application that is writing a log or it's writing to a database, all that goes into this read-write layer. Everything that is in the image is read-only, nothing changes, right? So the container has one more layer on the top where application can write data into. And when you tear down the container, everything is gone. Whatever was in the container is completely gone. You are having a clean slate, which is good in many cases, but there are cases where you want to store the data. Like if it's a database, right? I don't want the database to completely go away when I tear down the container. That's when the volume comes into picture. So volume is basically a folder that is on your host system, like on your host system, not on the container. So that's on your host system, just a directory that you mount onto the container. And when the container goes away, that is still there on your system. The volume is still on your system. So that's what volume is. Docker registry is just a registry to hold your Docker images. Now, Docker Hub is the one that is provided by Docker, but there are other container registries also. All the cloud providers have their registries as well. But the Edge5 images are on the Docker Hub. It's similar to the like how you have npm and different NuGet registries as well, right? So it's similar to that, where somebody can go download your images. So that's what Docker registry is. Build is the process. It's similar to, if you're familiar with software, it's the same thing. When you build the source code, what you get is a binary. In this case, you build the Docker file, and what you get is an image, and that image is what goes into the Docker registry that others can pull down. And when they run, they get a container, right? And then they can tear it down. So that's the process there. Then Compose. So Compose is a very lightweight orchestration process where, like, with the Docker images, each application, as I said, the best practice is that each application goes into its own container. That means for any production-ready application would need multiple containers. So everything wouldn't be in one container. So if there are multiple containers, then they need to talk to each other. Like database is in one container, application is in one container, cache is in one container. So then they all need to talk to each other, right? So that can be done without the Compose, but that will involve a whole bunch of extra command lines. But with the Compose, it defines how these different containers talk to each other. And with one command, you can deploy the whole thing. And then there is Kubernetes, which is the higher level of Compose, where in case it does the orchestration, but it also does scaling and making sure that the availability is there. So there is a whole bunch that Kubernetes can do, which is where we want to go. But right now what we have is Docker Compose as our MVP release in the last year. All right. Now I just want to go over a little bit of like how would you install Docker. So this is basically just for breaking the barrier of getting into Docker technology. So I am just running through this example here, just downloading a sample Nginx image from the Docker Hub. So you would download similarly for F5 also, right, later. But, oh, sorry. So right now I'm just going through the installation process. So I would go to Docker Hub, and then there is download and install here. And depending on your operating system, you would pick one option to download and deploy. So this is Docker Desktop. It's a utility that runs on your, like right now it's running on my laptop. So this would provide you the command line interface to build and create an image and then run it on your host as well, right? So for this, you do need to be on Windows 10 Pro or up, or Windows Server 2016. Again, like for the older versions, also there is another option, but not the Docker Desktop. So you would just download here and install, click through the run button and install. So once you do that, what you get is this. This is the Docker dashboard that, like right now it's empty, like I don't have anything running. I just cleaned up everything that I had for the webinar today. But this is where you would see your containers and applications that are running, and then images will show up here. I'll show again, like when I install something, I'll show again that it shows up here. So for many things that you don't need to deal with the command line, which I will show some of the command line as well, but for many of the things you can manage using the screen here. So like, yeah, in the screenshot here, I have some containers showing up, right? That's 5 containers showing there. All right.
So Maya, this might be a good time to ask you a question from one of our community members joining us, Sharad. How does the deployment of new code compare to using TeamCity or Octopus? Easier or same level of effort? Is it easier or same level of effort, just a different way of deploying the code? And I think you kind of answered that just now with what you just went through, but do you want to address that in any other way?
Yeah, so right now, the TeamCity does CI/CD full level, right? TeamCity and Octopus together. You are building your code, you're testing your code, and then you're deploying. Right now, the way the Docker deployments that we provide is based on the release packages. So what we have works if you are installing the released binary. So it's not building the application again. It's building the source code for the Docker, but it's not building the ODS API again. So now, if you had your own packages, if you had your TeamCity, if you have source code changes, now that what we have works well if you don't need any source code changes at all, right? All you need is deployment. Now, if you have source code changes, then you would push your, you would still have your TeamCity, which does your build, and it would create your binaries. You would push it up to a repo, and then you can work with the Docker source code that we have. So once you are familiar with working with the source code, you are probably familiar with working, you can get familiar with working with the Docker source code as well. Like I'll show, so this session is mainly to introduce that as well, right? Like I'll show the source code where you might want to change and tweak the source code to use your binaries, right? And then build your image and post your image and then use that, right? That is possible also. But what we provide by default, the images that are on Docker Hub is what we have already pre-built. So these are release binaries for the ODS API. So it just pulls it down and provides the deployment for that. Hopefully that answered the question shared. Otherwise, connect back later on Slack or email. All right. Okay, so now that we have the Docker installed, right? So after I ran, I have this, now I have installed Docker. Then comes, like, as I said, many things that are here probably can be done with the UI here. But at the same time, command line gives a lot more options. So I will switch over to that and show a few basic things here. So for this, I am going to just one comment before I switch over to that. So as I said, there is the Docker CLI, right? Like, how do I run the CLI? It's any PowerShell window, right? Like, you don't need any other different tool for running it. Any PowerShell window, just open the PowerShell window and run the commands. But in this case, I'm going to install this sample Nginx image from Docker Hub. So I would just go to the Docker Hub. I don't need to sign in or anything. Just picking this one image here. There is already a command to pull it down. So I'm just copying it out and running that through in here. So I talked about layered file system earlier, right, in the image. That's what you're seeing here right now. It's like downloading a bunch of different layers, like one by one. So that's what you're seeing here. So now it's done. Now just to check that it actually did download, I'm just running this Docker images command that it's showing that that particular image is downloaded, and there is the image ID, size, and the tag is latest. So this is one thing, like when you're downloading a file, then you would get the tag for that release, right? The release that you want to pull. Latest means it will get the development version. Okay, so now I have checked that the image is there. Now I want to, so this is just an image, right? So this is not a running container, and I want to run the container. So then I would run Docker run, and I'm using the same image name. Now Docker run would actually pull down. If I had not done Docker pull earlier, it would have pulled down. I just wanted to include that to be explicit here. So, and then I am going to give it a like one argument I need to send for this one is the port. Now here port is basically the 5000 is the host port, and 80 is the port that it would forward to. So 80 is the container port. So now I'm installing that. So I am just leaving that window open and opening another window here because I want to show something over there later. But now, now that it is installed, or I'm checking if it's installed or not, so running Docker PS would tell if there is a container. And it says the created and status is it is up and running. And now I'm going to go here and going to localhost, and as I said, port 5000 is what I gave here, right, to run it on the host port 5000. So I'm just running that, and there it is. The Docker container is up and running, right, with that one command. Now this is a basic container, so it does nothing much. So, but I just wanted to give that example, right? You also see that it requested, right, or request came through here. All right, I'm closing that. So then again, like you can do you can stop it, you can remove it. So there are a bunch of commands. You can stop it, you can remove it, you can clean up all the images. So so there is a bunch of commands for that. Docker. You would use container ID for this. anyway, so I wouldn't run through all in the interest of time, right? So these are a bunch of things that you can do on the, this means it stopped it. And then once it is stopped, I can't really reach it, it's gone, right? Anyway, I wouldn't run through these different examples because we are in the interest of time. Going through the next slide here. So a Docker file. So now we saw how to, so far we saw how to use the image that is posted on the Docker Hub, right? How does the image go there? So go to the Docker Hub. So that's where the Docker file comes into picture. So this is the Docker source code, right? Let me explain this with our source code here. 1 second. So I also wanted to like show this source code here to make it more comfortable, right? If you want to work with it later. So Docker file it's just a text file that you would build to get the Docker image, and it has certain language constructs, right? From is basically what the image is based on. As I said, it's a layered file system, and it is, you don't start from the scratch. You always reuse what is already there in the Docker Hub. So it's pulling down Linux, basically Alpine image, and then it's building onto it. And then label is just who's the maintainer, right? Environment, env is environment variable. So in this case, this is the version of the ODS API. So that goes into a command later on. Copy is basically copying what's in the repo, what other things are in that. Like in this case, it is copying the template and the log4net config and the run commands into the image, right? So that's what that is. And then it's pulling down the ODS API source code, the binaries from the Azure Artifacts feed, our feed. So we switched over from MyGet to Azure Artifacts, just to clarify that there. But that's all it is doing. It's basically pulling down the images that we have on the Azure Artifacts and building it on top of into the image, right? So these will add on to different layers of the image. Whatever is in the Alpine, and then all these commands add on to different layers in the image. And then it's just setting up the entry point as the run, which is basically starting up the ODS API. That's what it is doing in the run here. It's just running that API. So these are the different components on, yes, Carolina.
Vinaya, we have, I do want to just be mindful of the time. We're at 1:40. We do have a couple questions in the Q&A as well. I don't want to interrupt you at this point because I think like everyone, we're like learning how to do this with, giving us all this information, which is great. Let me know when you're at a point where we can wrap this part of it up and we can ask some of these questions that the folks on the line are wanting to know.
Yeah. So let me just show one more thing and then we can wrap. So this is the Docker file, right? And when you build, what you get is an image. Then I just wanted to go over compose. So this is just telling that from the Docker file, what we get is a Docker image, and that's what goes into the Docker Hub. So F5 already has done it for the core, right? Like all you do is you download it and then use it the way I showed earlier. So Docker Compose is basically combining different things. Again, like for the same source code, you can go there and check what it is doing, but it's basically combining all different applications together and binding them together. So that's what the Compose is doing. So these are different containers that go into the Docker, like the F5 core Docker. So that's what the Compose is doing. We can go into the details in case if there is time later, so I'm just moving on for now.
Okay.
All right, so then Yeah, I think
Go ahead.
we can wrap up and then come back later if there is time. These are like just slides. Like slide is available anyway, right, for folks, so they can go over and take a look at the configurations that we have. So let's go over the questions and then come back if there is time.
Yeah, and it might also be helpful for the folks on the line to know we can also, I think, and Vinaya, correct me if I'm wrong, it would be okay to make a PDF or just we can post the PowerPoint slides as well on our events page, because when we post the replay, you won't be able to click into any of the links that she's shown. Obviously, you'd have to look at the PDF to do that. So we can also post that of these slides if that would be helpful for the folks on the line. Okay, so we did get a couple questions. David asked, just a clarifying point, Postgres SQL is not a feature parity with MS SQL, correct?
Right now, yes. So this is only Postgres supported by, for the Postgres. So SQL Server is not included, mainly for the licensing reasons. And like this is what we heard as an MVP. This is what the field wanted. Postgres is the first thing. But there is a possibility that SQL Server support will be added later on. So this could be a field contribution. This could be internally developed. Not sure, but it is in the plan. Hopefully this year we will add that support.
Okay. And then another one from Sharad, does one license for SQL Server work for all containers?
It's the same question, right? So right now, SQL Server is not supported. But again, like we will try to do this at least for the cloud solutions where they want to run it on the Azure SQL, right? So that is one, and also default with the trial version or the developer edition of SQL Server is something that probably will come this year.
Okay, and a follow-up, the doctor can connect to an external MS SQL server.
Right now, with some little tweak to the Docker file, so you couldn't use the image as is. So there is some changes. Like you can use the source code, you can make a little bit of tweak and build your own image and use it. But with what I said just now, that we will be working on adding it. So hopefully this year, the support would be there, that external SQL Server connection would be possible.
Okay. And then Jose asked, we just moved from physical to a VM technology. Can we still go with Docker containers?
Yes, totally. So that's the biggest advantage of Docker, right? It can go on any environment.
Mm-hmm. Okay, so we've got most of these questions I think we did answer. So thank you, Vinaya, for that. I know that Jason Hoekstra had a couple really good questions that he also wanted to kind of just share. But maybe we can grab those for maybe this warrants a follow-up opportunity, because we do have so much interest in it and a lot more to say and you know, to share about this topic. So we might need to do a follow-up.
There is one question on the roadmap, right? What is there for Docker this year? So that's one thing I mentioned, right? The SQL Server support. Again, it's not explicitly called out in the roadmap, but that's what we are hoping for. We probably will try to get that in this year. The other one is district-specific and year-specific support. Right now, what is supported is the shared instance for the production, but district support and specific and the year-specific configurations support. So that's something that we will try this year as well.
Good. So before we wrap up, I'm just cognizant of everyone's time. It is 45. We're at the 45-minute mark. Are there any final slides that you wanted to share, or any additional information that we can share with the folks on the line?
No, I think I'm pretty much covered. So basically, the repo is here. Go through the code. So there is the option of either pull down the image from the Docker Hub as, directly, or pulling down the Docker source code and modifying it. So play with it, take a look at the code, and see if it fits your need, either modifying it and then building your image or using the image directly. If nothing, play with on the developer box and be comfortable with it. And it's awesome technology. So whether you're going to use it in production or not, something to take a look and learn from it, I think. But we do want you to focus and try to get it in production, because this is going to be a big cost saving for the district or the host. Yeah.
Okay, thank you, Vinaya, for your time and for your expertise on this. And that will conclude our webinar. And again, we'll send out the recording and the link to everyone that joined today. So thank you. That concludes the webinar.
Thank you.